For this final question, I've just set up in advance, while I was waiting for it to load, a series of ratios which are all the same. Now you'll see that if a ratio is the same as another ratio, if I do, like down this side, if I did 16 divided by A, if I did this value divided by this value, I'd get 2. If I did 8 divided by 4, this value divided by this value, I'd get 2. If they're the same, I must have had to multiply this side by 2 and this side by 2. I can do the same thing with these. If I do this left hand side divided by this left hand side, I get 2. If I do this right hand side divided by this, let's do that again, this right hand side divided by that right hand side, I'll get the same thing. It's not always going to be 2, but it's just a sign that you've times or divided both sides by the same thing. A ratio is the same. Let's think of one where it's not 2. So let's do, if I did 15 to 9, I know that I can simplify that to, divide both sides by 3, 5 to 3. If I divide the left hand side by the left hand side, I get 3. If I divide the right hand side by the right hand side, I also get 3. So ratios are the same when I can work out the scale factor between them and if it's the same on both sides. So this is to say, going from this one to this one, I've times the left hand side by 3 and I've times the right hand side by 3. Using this similar sort of logic, I hope it sort of makes sense. If these ratios are the same, let me just write one of them above the other. So 16x plus 1, I'll put a line through so we can actually focus on this question, to 2x minus 1. Underneath it I'll write down the ratio which we're saying is equal. This just means that they're the same as each other, they're equal. Then using the same logic we've got up here, the left hand side divided by the left hand side should be equal. So like here we did the left hand side divided by the left hand side, we got 2. We did the right hand side divided by the right hand side, we got 2. So it should be equal to if I do the right hand side value divided by the right hand side value, which should be a minus 4. Now, because this is algebra, it's not that easy to see that they're equal, but if we're told the ratios are the same, we know that these should be equal, they should be the same. These both represent like the scale factor, the what do I have to times both sides by. So if I cross multiply here, which means if I times both sides by x minus 4 to get rid of the denominator on this side, and times both sides by 2x minus 1 to get rid of the denominator on this side, I end up with everything on a straight line. So I've times both sides by x minus 4, I've times both sides by 2x minus 1. It says find the possible values of x. Now this is looking like a quadratic. We can only solve a quadratic if we've got one side equal to 0, so I don't really have any choice here but to expand my brackets on both sides. So I've got 16x squared minus 64x plus x minus 4 is equal to, and if I expand these brackets, 4x squared minus 2x minus 2x plus 1. Okay, to make one side equal to 0, I'm going to subtract 4x from both sides, which makes this 12x squared. This simplified would be minus 63x, and that would be minus 4x. Do you know what? I don't know whether I've missed too many stages out. I'll do another at the side here. 16x squared minus 64 plus 1 is minus 63x minus 4. Okay, and the other side was 4x squared. That would be minus 4x, the minus 2x and the minus 2x, that's minus 4x plus 1. So to make this, going back down here now, to make this right hand side 0, I've subtracted 4x from both sides, which is where the 12x squared came from. I'm going to add 4x to both sides, which takes me up to minus 59x. and I'm going to subtract 1 from both sides, which takes me down to -5. Now I'm trying to, first of all, if it's not a single x squared quadratic, you should be thinking, right, can I divide through by anything to make it a single x squared? Well, no. If I divide through by 12 here, it doesn't really help me with the other two bits because I can't divide them by 12. So I'm going to have to use the AC and B method. So AC, which is 12 times by -5, is -60, and B is -59. So what two numbers times to give me -60 and add to give me -59? Well, it'd have to be -60 and +1. So, using the AC and B method properly, I write the quadratic out again, but I split the middle bit into -60x and +1x, and then I factorise the first bit. So 12x squared and -60x, I can take 12x out of that. Just remember the second bracket will always be the same. So x minus 5, what needs to go in front of that? Well, that's easy in this case, it's a +1. So I've got 12x and the +1 and x minus 5. And don't forget that all the way from back up here, this should all be equal to 0. Now, I end up with 12x plus 1 and x minus 5 in brackets is equal to 0. I've run out of room a little bit because of all this explanation up here, so I'll tell you what, I'm going to bring this back up here just so I can explain the last bit properly. So I've got 12x plus 1 and x minus 5 is equal to 0. In general, the impression I get from class is people are quite comfortable going straight to saying that this would give you a solution of x equals 5. But it comes from the fact that from here, either 12x plus 1 equals 0 or x minus 5 equals 0. So if you rearrange this bit, that's where the x equals 5 comes from. The 12x plus 1, whereas people are quite comfortable from going from there to there, with 12x plus 1 people don't always know what to do with it. But if x minus 5 equals 0, x equals 5. You just add 5 to both sides. If 12x plus 1 is equal to 0, we just rearrange it step by step. So subtract 1 from both sides and divide through by 12. So x is either equal to 5 or minus 1 over 12. So down here in my answer box, x is equal to 5 or x is equal to minus 1 over 12.